So differential equations. The word differential you've seen before, right? When we see the word differential, just the word differential, what other word that we've heard of pops in your head? When you in this class, when you hear the word differential, sounds a lot like another word that we've used or words we've used before. Hmm? Differentiate. Yeah, exactly. Exactly. Differentiate. And what does differentiate mean? What does that mean? When we say differentiate, when you've seen differentiate, many, many, many times you've seen differentiate, right? What does that always mean to do? Mhm. Exactly. Find the derivative, right? So really, when we say differential equations, it means derivative equations. That's all it means. Okay, so we're going to be looking at a lot of equations that are derivatives. We're not finding derivatives. Here's the thing. When you see differential equations, you're like, derivatives? Why are we doing derivatives this semester? We did that last semester. We're not finding derivatives. They've already done that for us. Okay? What we're doing is we're starting with a derivative and going up in terms of finding the original, okay, equation. That's integration, right? So that's what we're doing. Okay, we're just looking at differential equations. Okay. So differential equations contain a derivative. So any equation that contains a derivative is called a differential equation. You've been seeing those since last semester. We just didn't call them differential equations. Okay. So it's really nothing you haven't seen before. You've literally seen all four of those equations. You've seen those last semester, right? dy over dx means derivative. Derivative, and if it has an equal sign, it's an equation, right? So any equation containing a derivative is called a differential equation. The order of a differential equation is the order of the highest derivative involved in the equation. The problem of finding a function y of x is given when its derivative and its value at a particular point is called initial value problem. So all of this is, in words, what we're going to do today. Okay, so here it's very wordy, it's very mathy. Okay, I'm not going to really focus on this, but that's essentially what we're doing. Okay, so what we're doing today is what we're going to be called solving differential equations. Solving differential equations. Okay, so what are we going to do to solve? One word: separate. Separate. Okay, separable differential equations are when we can separate when x and y are stuck together, when they're implicit, when they are stuck together like these guys here, right? Usually we have our y's on one side and x's on the other. Here they're together, right? Another example is this guy here is not a separable. It's already separated, right? Y equals 3x plus 2. They're already separated, right? Sometimes they're not. So what we're going to have to do today is separate them if needed. Okay? So that just talks about what we do. So our first big thing today is separating them. Separating the x's from the y's. Okay? So separable differential equations are different equations where the variables can be separated. Okay? So we're going to do a couple examples. So here are our steps for that. There's 4 steps. They're not very hard because you've done them before. You've done everything on there before, either in this class or a different class before that. Okay? So if needed, this is how we solve by separation of variables. So we move everything with a y to the left side of the equation. We move everything with an x to the right side of the equation. Okay, even dy and dx's, we separate those. Okay, Any constant that doesn't have a y or x goes to the right. Okay. Integrate both sides. So we integrate both sides. That gets rid of the dy's and dx's. Okay. And then because there are no bounds when we integrate, we got to add a plus c to one side. You don't have to do it to both. If you are given a point, then plug in the point and we have to solve for c. Okay. And then the last thing is solve for y. So all four of those things we've done before. They're not hard things. It's just, it's a new concept. Okay. Okay. So first one. We have to solve the differential equation dy over dx equals x sine of x using separation of variables if y sub 0, so this is a point on the graph, 0, 2, okay, for this case right here. Okay, so the first thing is, so I'm going to rewrite it, dy over dx equals sine of x. That's the derivative. We're going to use separation to find the original. And not only when the original, but when the original had a 0.02. That's what we're going to do. Okay? So y's on the left, x's on the right. Y's on the left, x's on the right. What's the only thing we have to move? Or do we have to move anything? Y's on the left, so just like we do in Math 1, draw the river. One side is the left, the other side's the right. So on the left is the y's. On the right are the x's. Now, do I need to do anything to, or is it already done? Is that already done, or do I need to do something? I have to get dx to the other side. Yeah, I have to get dx to the other side. How do I do that? Yeah, yeah. You just said that. Yeah, right. Multiply both sides. It's division, right? The opposite is multiply. So if I multiply dx by both sides, just like you've done many, many, many times before, right? It's an equation. You multiply one. If you do one thing to one side, you have to do it to the other side as well. Okay. The dx's cancel out. They don't really cancel out. They make a 1 and a 1 here. If we want to be mathematically correct, because anything divided by itself is 1. So now we have dy equals sine of x dx. Okay. Happy then? Okay, that's the first step. Second step, integrate both sides. Integrate both sides, okay? We know how to do that. We just had a chapter on that whole thing. Integrate both sides. I know how to integrate the right side, right? What is the antiderivative of sine x? Remember the wheel? To go clockwise is derivatives. We got to go the opposite. So what's the antiderivative of sine x? Negative cosine. Negative cosine x. We're going to put a plus c. We only need one plus c. We don't need plus c's on both sides. I always do it on the right. Okay. All right. What's the antiderivative of the other side? Mm-hmm. Yeah. Why is it y? How do you get y? That's right. It is y. Where do we get y from? Because I know a lot of you would look at this guy and be like, how do I find the antiderivative of that guy? Why is it y? Mm-hmm. Because there's a 1 in front. Yeah, there actually is a 1 in front here, right? So really what you're finding is the antiderivative of 1, right? No power. So we add a power, y to the first, divided by 1, which is just y. Okay. All right, so we did that. Let's go to step 3. Step 3, if you are given a point, plug in the point and solve for C. So what do we plug in? I'll give you a hint. You're going to use this guy over here. So what do we plug in to solve for C? I got to solve for C now. What are we going to plug in over here? There you go. 0 for X, 2 for Y. So I'm going to rewrite it. 2 for Y, 0 for X. Solve for C. Okay. Well, what is cosine? I'm not worried about the negative right now, but what is just regular cosine of 0? Positive 1. Now throw in the negative. You get negative 1 plus C, right? Last step. Add 1 to both sides. You get C by itself. Okay. Step 3 is done. Step 4, solve for Y. Okay, so I'm going to plug it, then substitute the value you found in for C. Okay, so I got it. So I'm going to plug back in the value I found for C. So Y equals negative cosine X plus 3. Last step, solve for Y. Well, this one's already done. We already solved it for Y. It's already done. So we don't have to do that step, okay? Most of the time, you will have to do that step. But for this problem, you didn't have to. It's already solved for Y. Okay? So before we go on, I want to focus on 2 things. These 2 guys are technically the solution. They just have different names. This guy over here, it's a different color. This guy over here is called the general solution. Sometimes they just want the general solution. If they just want a solution in general, that's the guy with plus C. Sometimes they want the specific or particular solution. Right? That's what that guy is. Okay? So it just depends on the wording. Sometimes they want just give me the general. Sometimes they want the specific solution or a particular solution when something else is true. Y of 0 equals 2. Okay, so they're both technically a solution. They just have different names. Okay. All right, let's look at the next one. Okay, so the next one, find the general solution for the equation f of x equals the integral of 3x squared dx. Then find the particular solution that satisfies this condition. Okay, so this one's a little different. This one's a little different in how. How is this one a little different? Yeah. Yep. Y is replaced by f of x. That's the first thing, right? Easy enough fix. That's one thing. What's another difference? What's another thing this guy is different that we haven't seen? We didn't see in the last problem. Yeah, they don't start us with, usually they started us with the differential, right? This isn't the differential, right? This guy is not the differential equation. This guy is the actual f of x, right? So we're going to have to change it up a little bit, right? We're going to have to change it up a little bit because there is no dy over dx. How do you separate dy over dx if there is no dx? All right, okay, so let's take a look at this guy. All right, so let me rewrite this. So f of x okay. Again, there's no y, but we can change f of x. F of x is really the same thing as y. Okay. The only difference in this one is that I don't have to integrate the left side because that one's already y. I don't have to integrate this side over here, right? That's the only difference because if this was a dy over dx, then I would. But since it's not, I don't have to. So I just integrate this side over here. Okay? So finish it out. What do you get? What do you get when you integrate that side? Okay? What do you get? This problem's easy compared to the ones you guys had on your group tests and individual tests. So you guys will be able to do this one. What do we get? Mm-hmm. Yep, y equals x to the third, right? Because we got to add 1 to the power, divide by that new power. Those end up canceling out. You just get x to the third. Since there were no bounds, we want to put a plus c, right? General solution. They wanted us to find the general solution, so this is the general solution. That's important to note. Okay? And then they want us to find the particular solution that satisfies f of 2 equals -3. Okay? So plug in 2 and -3 and see what you get for C. Okay, so -3 equals 2 cubed is 8. Subtract 8 from both sides. You get -11. Okay, so let me put that one back in. That's the particular solution given okay. All right. Okay, so that one we didn't have to integrate both sides because one side was already done for us. If we have a differential equation, we're going to have to. Okay. All right, let's look at this example here. Okay, so in this example, read it to yourself real quick. I'll give you about a minute, 30 seconds to read it to yourself. Okay, so you see acceleration, we see velocity, we see position. We've seen those before. What's the relationship between acceleration, velocity, and position? What's the relationship between them? Mm-hmm. There you go. Keep going. Exactly. They're derivatives of each other. It starts with position, then velocity or speed. Remember, speed is just the absolute value of velocity. So whatever you get, make it positive, and that's speed. And then the last one is acceleration. Right? So if we want to go down the list, if you want to go down the list, you need to derivative, differentiate, right? If you want to go up the list, you got to anti-differentiate or integrate. Okay, so let's see where they start us. Starts us with the acceleration. So they say the acceleration and then they want us to find the velocity and the position if v of 0 equals -1 and v of s equals +1. Okay, so we start with acceleration. What do? You guys might not know the mechanics, but you should know the steps of what we're going to do. What are we going to do? At this point, you guys should be able to do this on your own, but we'll talk it through. What are we going to do first? What's our first step? Integrate. Yeah. We need to go up the list. We need to go up the list, right? That's the critical thinking skills right there, right? If you look at it and you're like, oh, I don't know what to do, then I can't do anything for you. But if you see it and you're like, we're at acceleration, we need to go up the list, that's integration. You guys should know that. So integrate, what do you get? So the antiderivative, what's the antiderivative for acceleration? What's the antiderivative for acceleration? Velocity. Okay, so v of t equals the antiderivative of cosine. What's the antiderivative of cosine? Sine, positive sine of t plus c, right? And then they said, hey, for cosine, or sorry, for velocity, this is going to be true in yellow. Okay, so 0 is t, -1 is v of t. Okay, so -1 equals sine of 0 plus c. What is sine of 0? 0. So that means c equals -1. Okay, plug that one back in. So velocity equals sine of t minus 1. There's one of my answers. I found velocity. Now that's going to be my starting point to find position. Okay, so let me start right here. V of t equals sine of t minus 1. That's my starting position. What do I do? Not the derivative, because that'll take me back to acceleration. There you go. Find the antiderivative. Integral, right? Integrate. There we go. So the antiderivative of v of t is s of t. S of t is what they use for position. Okay. So now this guy has two parts. So really you're just finding the derivative of one and finding the derivative, or finding the antiderivative of one, finding the antiderivative of the other. So what's the antiderivative of sine? Negative cosine, yep. Negative cosine of t, good. And then what's the derivative of just 1? T to the first divided by 1, which is just t. Plus c. Good. That's the general solution. Now we know that s of 0 equals positive 1. So when t is 0, 0, 0, 0, that should equal positive 1. Okay, so let's plug in what we know and solve for t. Negative cosine of 0 minus 0 plus c. I think earlier we did sine of 0 or cosine of 0. What was cosine of 0? 1. With the negative, it would be negative 1. And then 0, it just goes away, plus c. Add 1 to both sides. We get c equals 2. Okay, done. So it's the same thing, just using velocity, acceleration, and position. So you're going to see problems in the future where it talks about this. Okay, as long as you know that position is the antiderivative of velocity, velocity is the antiderivative of acceleration, or velocity is the derivative of position, acceleration is the derivative of velocity, you have a starting point. Okay, and we know that already. We know that from last semester. Okay. Okay. Let's look at the next one. Okay, so position, velocity, acceleration, not here, but it's essentially the same type of thing, right? We have a differential equation. So now we have a differential equation. The derivative equation is dy over dx equals x squared plus 3 over 3y. So before we can do the 3y of 3 equals negative 4, before we can touch that, because that's the particular solution, we got to find the general solution. So step 1, set separate. Separate. Y is on the left, x is on the right. Okay. Well, I'm going to do the same thing I did for the last one. I'm going to multiply both sides by dx. I get rid of the x here. So I get dy equals x squared plus 3 over 3y dx. What else do I have to do now? What else do I have to do before I can go to the next step? There you go. Yep. I have to move the 3y to the other side. Since it's on the bottom, I have to use multiplication, just like I did for dx. So I'm going to multiply both sides by 3y. 3y's over here will cancel out. Okay. So on the left side of the blue line, we have the y's. On the right side of the blue line, we have the x's. 3 doesn't have anything, right? So I just leave it there. Just leave it there. Anything, any constant that doesn't have a y or an x attached, just leave on the right side. Make it easier on yourself. Just leave it where it was. Okay. So now that's step 1. Step 2, integrate both sides. Okay. So we have too many antiderivative problems. Okay. So on the left side, it's with respect to y. On the right side, it's with respect to x. That's what the dy and dx means. Okay. So power rule will work for both. We don't have to use any u substitution or anything like that. Power rule works. So over here, we're going to get 3y squared divided by 2. Okay. Over here, we're going to get x cubed, or 1/3 x cubed, because it's divided by 3, plus 3x plus c. Okay. Next step, plug in what we know. Now we can plug in what we know. We know this piece right here. Y of 3 equals -4. That means when I plug in 3, I should get -4 as an answer for y. So everywhere I see an x, I'm going to plug in 3. Everywhere I see a y, I'm going to plug in a -4. Okay. So the only letter left is c, so I can solve for it. Okay. So let's see here. We get 3/2 times 16. And then over here we get 1/3 times 27 plus 9 plus c. Okay, so over here I can divide these both by 2. That becomes a 1. That becomes an 8. I can divide these both by 3. That becomes a 1. That becomes a 9. So over here I get 24. Over here I get 9 plus 9 plus c. So I get 24 equals 18 plus c. Subtract 18 from both sides. I get 6. C equals 6. Okay. So this guy up here, I'm going to move up here. Plus 6, because I know C is 6 now, right? What's the last step? We didn't have to do this. We haven't had to do this step before, but now we do. And this step is the most, it's the least, probably the least calculus part of what we need to do, but I'm telling you right now, it's probably going to take the longest sometimes. Sometimes it'll take the longest, sometimes it won't. What's that last step? Solve for what? Yep, solve for what? Okay, solve for what? So like I said, this has nothing to do with calculus. This is just isolating a variable. You guys have been doing that probably since 6th grade, getting x by itself, getting y by itself, right? That's what we have to do. So we have a 3/2 being multiplied times y, and we have a squared. We have to undo both. So the first thing we're going to do is get rid of the 3/2. So what operation am I going to use to get rid of the 3/2? Multiply by the reciprocal. Multiply both sides by the reciprocal. Those will cancel out, all become 1s. Now over here, I have to multiply everything by the reciprocal. Okay, so let me rewrite this. Y squared, I'm going to move the 2/3 to the front. Now, a question I get is, do I have to distribute? It's up to you. I've seen it both ways. I've seen them distribute on answers. I've seen them not distribute on answers. More than likely, this is going to be a multiple choice question, so you just match whatever they have. Okay? If it's easy to distribute, I would distribute. Like this one's pretty easy to distribute because you got a 2/3, and then you have a lot of things that 3 goes into. So if you distribute, you're going to get 2/9 x cubed, and then you'll get 2x, and then you'll get 4. So maybe that one might be, might not be bad to distribute. So over here you get 2/9 x cubed, and then you'll have 6/3, which is 2x, and then you'll have 12/3, which is 4. Okay. That part, I'm not really concerned about. The distributing part. If this was a Math 1 class, I would be very concerned about that. I would make sure you guys distributed. But you guys are way past that. Okay. We're not worried necessarily about that. We're more worried about solving for y. Okay. Last step. How do I get y by itself now? Root. Yep. Find the square root. Done. Leave it like that. Leave it as a root. Don't worry about simplifying it. Don't worry about that stuff. Just leave it as a root. Okay, it's a square root. You're done. You leave it like that. You don't worry about that stuff. Okay. So really the only calculus in the 4 steps is step 2, integrate. And you're going to find that that's probably the easiest step to do because you guys are used to that. It's step 1, separating them. Step 3, solving for C. Step 4, solving for Y. That's going to take you the most amount of time. You'll see that. You'll see very quickly that step 2 won't take you very long. Okay? All right, so now I want you to try the next one on your own. I'm going to give you about 5-7 minutes. Do the next one on your own. Get as far as you can. If you get it right, great. If you don't get it right, this is notes. It's important to know where you went wrong instead of that you got wrong. Okay, it's important to if you get it wrong, where did you go wrong? Was it little? Was it big? What was it? Okay, so I'll give you some time. Go for it. Okay, so I did the first couple steps. I haven't finished it. So I separated variables. I left the negative with the x on top. Okay. It's not going to change anything. It won't change anything in the answer. Your answer will still be the same, but it'll just look a little different if you move the negative to the bottom with the 2y squared. Okay, so I integrated, and then I plugged in 3 for y and -6 for x, and I got 36 as c. Okay, that's where I stopped. My next step, I'm going to plug in 36 back there. -3. -3, -3, -3. Oh, yep, -3. That'll make it -27, which is -18, which is 0. So C is 0. Okay. So that means you're just going to have a 0. You don't have to write the 0 in. You can if you want. So now what I'm going to do is I'm going to rewrite this guy over here. You can write the plus 0 in, or you don't have to. It's not wrong either way. Most people just don't write it in. Okay. Now I have to, last step, solve for y. So I'm going to multiply by the reciprocal. So over here, I'll get negative 3 over 4 x squared. Okay. Third root. So I get y equals the third root of negative 3/4 x squared. Okay, you don't have to do anything with that. You don't have to solve from there or anything. You're done. That's it. Okay. If you want to check your answer, if you're ever on a test and you want to check your answer, you're like, I don't know if that answer right. Just find the derivative of this guy. If you find the derivative of this guy here, you better get that guy there. Okay. That's what it is. It's the antiderivative. This guy is just the antiderivative of this guy over here. Okay. All right. Okay. Let's see here. Yep. We're not going to have time to we'll start with this one tomorrow. Okay. We'll start with the next one because there's a couple different things you're going to see, and we're not going to have time with those in the 5-6 minutes that we have. Okay. So keep these, and we will continue this. We'll finish up